movie? I've never seen it.
Yeah, we're going to do a little bit of how it works when you have a hole in one of the functions. Still working with slants and things like that. Kind of basically just do the same stuff. The one thing we haven't talked a lot about yet, or I think you actually had a problem like it, I think Colton, you brought this up the other day. There was one of our functions that had something that factored itself out. And what happens here is that if you have common factors when you're dealing with one of these types of problems, one of the asymptotes kind of disappears, like the actual drawing of it, but yet there's what we call a hole in the curve, or hole in the graph. So if I'm looking at the function, f of x is x squared minus 9 over x squared minus 2x minus 3. The first thing we're going to do is just factor everything and just see what it does before then we'll start listing out our zeros and all that other junk. So x squared minus 9 is the difference of squares. You wind up with x minus 3, x plus 3 in the numerator. In the denominator, you get good. Denominator, you get x plus 1 and x minus 3. Now, you'll notice what happens is that you get your x minus 3 is dropped. And when your x minus 3 is dropped, you get a hole, okay? It's that common factor. You have eliminated a possible value for an asymptote because it goes away. So your asymptote, your only vertical asymptote is going to be at x equals -1. Now, what I want you guys to do is see what happens when you have the curve in your calculator. Let's go to our calculator and put this in.
The whole thing, or like the...
Yeah, the original function. Got a graph. Fraction. X squared minus 9.
Oh, you messed up. Mr. Murphy, how was your day?
It was nice. How was yours?
It was good. What did you do?
Hung out with the boys. Bless you.
Hang out with Moose, or did you hang out together?
The other one is Connor. Yes, all three of us hung out together.
Aww. Did you guys Caitlin? Did they not have school?
No, they had school.
They
So
go to Caitlin? What? His wife
His
works
wife. She goes
yes, my wife is a head of
to just see.
Is there more than one? Or my sister? Because my friend is like, she goes to Caitlin, so I asked if
From Grays Lake.
No.
I think you said my friend from Grays Lake goes to Canada. That's a heck of a drive.
No, my friend from dance goes to Caitlin, and her brother like is in high school, so I asked if he like is shipping.
There might be. I don't know.
And she like when I said it, she like started talking about like some Murphy, and she started talking about like her kids that they like.
Oh.
You should get your wife to take this.
So yeah, she teaches chem and AP chem over there. But yeah, Moose goes there because they have preschool. So they have in-house preschool. Anyway, but no, the three of us just hung out. We went and ran some errands and went to the training park out in Rochelle and had lunch in my truck, in the back of the truck, watching trains go by. It was fun.
Like that's what people do. And I was like, do you just like sit there and watch the trains?
Yeah, it's awesome.
you're right.
The kids love it. My kids absolutely love it. We sat there for a couple hours. We brought a picnic lunch, sat in the bed of my truck, and watched a dozen trains go by.
It was really nice out yesterday.
It was. Love it. Anyway, back to this. It was over x squared, and then it was what, minus
2x minus 3.
minus 3?
Yeah, plus 3.
That was minus 3.
Yeah.
Okay. So then, go ahead and screw up. We get something that looks like this.
Yes.
All right. Now, what I want you guys to see here is that when you simplify out a common factor, you have eliminated one of the possible vertical asymptotes, and you also eliminated one of the possible x-intercepts. But when you look at the table, watch what happens on the table. Remember, hit menu, 7, thank you. Enter. See what happens when I get to 3 on the positives? I get an undefined value. What this means is that there's a hole in the graph. It's not an asymptote, it's just a hole in the graph. Because the common factor, when you get a common factor like we have here at 3, if you are graphing that, what is that? 1, curve look like? Doing this kind of, right? What happens is you put an open circle where it's undefined. That's why I said it's called a hole. You put a hole in it. Because you're not going to be able to use 3 for that value. It's discontinuous at that point. Okay?
Wait, is it
Yeah, there's going to be a horizontal asymptote at 1 at this one. And I haven't gotten that far yet, but you're right, because of our degrees are the same, so it's going to be the fractional amount of the coefficients.
Wait, did you just like put it through right there?
I just drew a curve and put a hole in it. Because what's happening here is that this value of 3 doesn't work, but yet it still shows, it doesn't come up as a straight asymptote.
No, but like when you went through the line, it's supposed to be.
I just saw it looked like it was at 2, so that's why I just drew it through. That's all.
Actually, looks
Oh, whatever. How about this? Is that better? Okay. The idea here is if you have a hole, you're just going to draw a hole in it. Okay. That's basically what I'm talking about here. You go through the rest of it, you still hit your, hey, what's up, how are you?
I'm doing well. Third time the charm. Dustin.
He's here.
This time I peeked through the window. I'm like, all right, I got him.
Nice. Well, we like to see your cheerful face.
Hey, I like coming by. Hopefully I come by just to say hi and not to pull somebody out.
That's all right. Yes, sir.
So when you're looking at the graph in the calculator, you won't know whether or not there's a hole in it.
Right. And the idea that there's going to be a hole is when you have a common factor.
Okay.
That's what happens. If you get a common factor that factors out, the hole is going to be the 0 of that factor.
Okay.
Okay? Does that make sense? The hole is going to be the 0 of, I shouldn't say the factor, we should call it the term, because that's what we usually call it. Whatever the 0 is for that term. The table button?
Menu. You can press control. Oh,
Menu.
that works.
What worked?
How'd you figure that out? Control T.
Control T? How do you know that?
It I
does?
asked her, she said, because she's a genius, so she's obviously smart.
Hey, Control T!
What? Good job, Tessa.
I didn't know that. Tessa. Terrifying. Nice. I didn't know that. Does that help?
Tessa would crack her.
The table's working? Do you need like a sugar packet underneath? It's not
She can't
wobbly?
even grab that one. There she goes.
Yes.
I would have laughed.
Okay. I don't know why you're doing this, so you have to go to menu, review.
Well, like this doesn't look good.
Just work until like 5 o'clock. I don't know how you go check on the paper or check
You want me
on
to
the
tell you?
paper.
Just talk to me. Just to finish out the graph then. So this one tells you had x-intercept at -3. We did our vertical asymptote. Our domain here, our domain then, when you list out your domain, what do we write out? Well, you have to throw it at your zeros are still gonna be both of them from the denominator, because did 3 work?
No.
So it's gonna be everything but your asymptote and that whole.
Okay.
Oh, so you
So like
include the
all
one?
reals except
So negative
-1 and 3.
Yeah, because there's a hole there, and it won't work. Alright? The horizontal asymptote we found because the degrees were the same. Since the degree of the numerator and the denominator were the same, all we had to do was just take the fractional amount for both of them, and that's where we got the y equals 1 for the horizontal. My curve is just a little bit off, but.
Wait, how'd you get that one?
When you have, remember we played the game of degree war
Oh,
for
yeah.
these guys? So if the degrees were the same, you just do the fractions. See, I have another one here I wanted to walk through with you. This one won't have a slant because their degrees are the same. You get the slant when your degree of the numerator is 1 more than the other, and that's usually a squared and a constant term. Let's try this one. Walk through this one again. Same basic idea. We're going to list everything out. F of x is x plus 3 over x squared minus 9. So you wind up with when you simplify that, what do you get? Thank you for remembering that there's a 1 in the numerator. Okay. And we also know that, so x can't equal -3 or positive 3 because it's going to have that hole. But which one is going to have, where's the asymptote going to be? It's going to be at 3 or -3? 3. The hole will be at -3. The hole goes to what zeros it's so that simplifies out. The asymptote goes to the actual 0. What's up?
Wait,
You okay? Yeah, because then you just wind up playing, yeah, because then you, yeah.
Wait, why can't it equal negative?
That's our hole,
Or what?
because it simplified itself out,
Okay, well, why can't it equal positive?
because that's the 0 then. So if you start, if you remember, you get, when you look at it, you're going to have that vertical asymptote at 3, but somewhere in the curve, you're going to have a hole in a curve somewhere. Okay. And if I look at the graph, reset this one. It's x plus 3, correct? That's why it doesn't work right when we press it. Interesting. And then it was x squared minus 9. It calculated. And if you look at your table, using my Control T, if I scroll through, see at -3, it goes undefined again. Not so scary? Want to do another one, or are we all right? You have day 3 now. Yeah. We